All right, our next step is percent phosphorus, and this is percent phosphorus in the fertilizer. So remember what a percent is, it's just the part divided by the whole. So I'm going to take my part, which is 0.270 grams of phosphorus, divided by my original sample of the fertilizer, 2.731 grams of fertilizer. And then we're going to multiply it by 100 to get to a percentage. And so if we do this math, I end up getting 11.7% phosphorus in the fertilizer sample. So again, you're going to do that exact same. Take your mass, divide it by your mass of your fertilizer, take your mass of phosphorus here, and divide it by your mass of your fertilizer. So go ahead and get that, and then come back to me. Okay. All right, next. Okay, so once you have your percent phosphorus, you have 3. We're now going to do an average. Of course, how do you do an average? You add all 3 up and divide by 2. Oh, I'm sorry, 3, because there's 3 samples. Sorry. All right, and mine ends up being exactly 12.0%. Okay, so this is the average or the mean. And so in order to calculate standard deviation, we're going to see how close we actually are to the mean. So the first thing you have to do is you have to compare how close your average is to each one of your samples. So you're going to take the absolute value of your average minus your sample. Okay, so you see, take the average, and again, you subtract each sample from it, and you're going to get, whatever, but again, just remember to take the absolute value. We don't need the negatives. And I get 0.3, 0.2, and 0.2. Now, why am I not going out another digit? It's because here I am, since I'm subtracting, you go to the actual place value. Our place value goes to the 10th, so that means I'm going to only go to the 10th on here. And then in order to calculate standard deviation, okay, so you're going to take the square root of each one of your differences here. So 0.3 squared plus 0.2 squared plus 0.2 squared, okay? And we're going to divide that by however many trials we have minus 1. So we have 1, 2, 3 trials, minus 1 is 2. So it's the number of trials minus 1. Okay, so that goes on the bottom. And then we're going to take the complete square root of that. So again, square, 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 divide by the number of trials minus 1, which in our case is 2, and then take the square root. Okay, go ahead and work through yours. All right, so when I do mine, I end up getting a standard deviation of 0.29. Now, it usually what they say is any result that's outside of 2 times the standard deviation is one that's not right. And so, actually what we're going to do, we have to flip over to the other side here. I'm just going to tear it off. So it says, do any of your results differ from the mean by more than 2 standard deviations? So my standard deviation was 0.29. So that means 2 times my standard deviation would be 0.58. So my mean, my average was 12. So my high end on this could be 12.58. Okay, that's my high end. And then my low end is 12.0 minus 0.58. And that's 11.4. I don't think that's right. 4.2 maybe. I think that's right. 4.2. Okay, that's my low end. So as long as my results of my 3 trials are within there, that means they all count. So let's go back. 11.7, 12.2, 12.2. They are all within this range. So do any of my results differ by the means of one? No. They're all within. So we're going to keep them all because they're all within the standard deviation of 2 or more than within 2 standard deviations. Okay, now so that was accurate. That was checking our precision. How close our 3 samples were together. But now we're going to try to figure out accuracy. So how close are we to the reported percent phosphorus? So remember, guaranteed minimum percent phosphorus on the label bottle. It was 20%. Okay. We need to figure out exactly how many, what that relates to hours. Now, okay, reported percent phosphorus. Okay, it said it was 20, but remember now we need to go through this thing of, okay, that's, we're going to convert that from phosphorus into, hang on, not enough light for my calculator. Okay, so if it's 20% phosphorus, we're going to assume a 20 gram of P2O5. We're going to assume a 20 gram sample of 20 grams. And if we're going to go from 20 grams of P2O5, remember this is P2O5, we're going to try to get to phosphorus. So first of all, we need to divide by the molar mass of P2O5, which is 141.9. So we're going to divide it by 141.9 equals. Okay, so this is how many moles of P2O5. But now you have to remember it's for every 1 mole of phosphorus, for every 1 mole of P2O5, it's 2 moles of phosphorus. So we're going to have to multiply this by 2 in order to get to the number of how much phosphorus. So we're going to multiply this by 2. All right, and then we're going to multiply by the molar mass to get to phosphorus. Okay, so reported percent phosphorus. So that would be our percent phosphorus on here. That would be the reported that came off the box. But what we really want to do is we actually want to be able to take what our average, so ours is 12, okay? So ours is 12.0. But we're actually going to compare the percent to P2O5. So now we're going to take our average percent phosphorus and turn that into P2O5, okay? So now we're going to essentially do the exact opposite of this last step. Okay, so we have 12. I'm running out of room here. No places to go. I'm going to turn this down here. So we have 12. Instead of, if it's a percent, we're going to assume 100 grams. So it's 12 grams of phosphorus. Okay, first thing we need to go to moles of phosphorus. And how do we go from grams to moles? Divide by the molar mass, which is 30.97. Now this time, and now we have 2 phosphorus for every 1 P2O5, so we're going to divide by 2. And then to get to P2O5, we're going to multiply by the molar mass of P2O5, which again, 141.9. And so when you do 12 divided by 30.95 divided by 2 times 141.9, I end up getting for mine, where's my sheet? 27.5% P2O5. So, are we within, oh, I'm sorry, that's supposed to go up here. Are we within 2 standard deviations? No, that's more like 26 standard deviations. So when it comes down to it, our accuracy was very, very poor on this. Our precision was great. We were within 2 standard deviations, but our accuracy was poor. And so that pretty much tells us there's something in this technique that doesn't quite work. Who knows if the samples are still too heavy, and that might be it, or whether we're just we're creating let's just say the wrong kind of salt. I don't think that's it. I think it's mainly that our samples are just too heavy. Okay, so that's kind of a work through on that. I think I only have you do number 2 of the problems, and then, which is, again, it's just finding this percent. It's just finding the percent. Again, you're going to start with this salt, divide by the molar mass, it's a 1 to 1, and then multiply by phosphorus. And then this last one here, this is actually just a straight stoichiometry problem, just because it's good to practice it. And then you have your pre-lab questions. So hope this helps. If need be, we can go over this. I don't think I'm gonna make the lab due until, let's make the lab due Wednesday instead of Tuesday, the day of test day. But you will definitely want to be able to have gone through this, because there are questions on the test about the lab. So you will want to at least seen this and kind of worked through this a bit. Okay, hope this helps. Bye.